So, good morning, Year 13. Again, we're going to tackle another mountain. We're going to learn how to integrate functions like this. They're called rational functions, but I didn't want to clutter your brains with too much at the moment. But they're called rational functions because they're written in terms of a fraction. A piece of algebra divided by another piece of algebra, but they can get really fearsome looking like that. There is a polynomial on the top divided by another polynomial on the bottom. And we need to know how to tackle these sorts of things, especially for integration. However, the very first thing you've got to learn is how to do long division. Now, you probably may have seen this in intermediate or at some time in the past, but this is how people used to do things long ago before there were things called calculators to do it for them. Now I'm going to show you, I'm going to take you back to your intermediate days or your primary school days or maybe no days at all in which you've ever done this before. And I'm going to show you how to do long division with numbers. And the reason I'm going to show you how to do long division using numbers is because the method used is very similar to, well, it's not similar, it's almost exactly the same as what we're going to use to do the division of the polynomials, the algebra here. Okay, so first of all, let's look at how you do the following numerical long division. Well, here I've got 5,697 being divided by 5. So the thing that's being divided is this thing here. So you put that underneath a little bar thing like this, and the thing that's doing the divisor, the 5, goes there. And now the way you do this is you first of all do this, you look at this digit here. And this is 5, and you say 5 divided by 5. Well, I've done it on the side here. 5 divided by 5 is 1, so you put that 1 here. Now, you take this 1 and you go 1 times 5, this 5 here, this 5 here. You go 1 times 5, and you write it underneath this 5 there. So 1 times 5 is 5. You draw a line, and you take away. Okay, so you go 5, take away 5. Well, it's 0. Okay, now you bring down this 6 to here. And now you do this 6 divided by this 5. Just as we did this 5 here divided by 5, we now do this 6 divided by 5. But we write it like this. We bring down the 6, and we go 6 divided by 5. Well, 5 will fit into 6 once. Yes, there is a remainder, but don't worry, we'll sort that out. So you go 6 divided by 5 is once. So you write that here. Now you do again. You multiply this 1 by the 5, and you put it underneath the 6. So 1 times 5 is 5. There it is. Now you subtract again. You draw a line. So you go 6, take away 5. Well, that gives you 1. Now you bring down this 9 and you write it there. That looks like now 19. And that's exactly what it is. So you now say 19 divided by 5. Again, this 5 here. So it's 19 divided by 5. Well, the answer is 3. Okay? Because 3 5s are 15, but there is a remainder. Okay, don't worry, you'll see how that comes into play in a minute. So 19 divided by 5 is 3, and you put that here, this 3 there. Now you go 3 times 5, it's 15, and you write it underneath the 19 here. So you write 15 there, and you subtract. So 1 take away 1 is 0. 9 take away 5 is 4. Great. Now you bring down this 7 all the way to there. And now you do 47 divided by this 5 here. There it is. 47 divided by 5 is equal to 9, because 9 5s are 45, okay? Yes, there is a remainder, but don't worry. So the answer is 9, goes 9 times, and then we multiply 9 times 5, which is 45, and we write it underneath the 47 there, and we take away. 4 take away 4 is 0, 7 take away 5 is 2. Okay, now this 2 is our remainder. So the final answer is that 5,697 divided by 5 is 1,139. There it is there. Remainder 2. But this remainder is what really? It is really 2/5, because we're dividing this thing here by 5. So we've got a 2/5. This 2 here, we've got 2/5 remainder. So a more complete answer would look like this: 1,139 and 2/5. Of course, we don't usually write this plus there. We usually write the 2/5 right behind the 9. So it goes 1,139 and 2/5. But it really is being added on to the answer there. That's important because we're going to be doing that right now for the division up here. So let's go back up here and see how we do a long division using our long division of polynomials. All right, now hopefully you've understood all that went on there, because we're going to be using a similar process here. Okay, now this 2x plus 3 over x plus 2 really means this 2x plus 3 is being divided by the x plus 2. So we do the same thing as we did here. We write it like that. This is doing the dividing. This is being divided. Okay? So what we do now is we take the 2x and we divide it by this x here. Okay, and there I've done it there. We go 2x divided by x. Well, those x's cancel and leave you with 2. Now I put the 2 here in the number column, not over the x. Okay, you'll see why when I do a harder example, why I've done that. So we do the 2x divided by the x, and we get 2. We write it there. Now we multiply back. 2 times x is 2x, and now we write it in the x column. And 2 times 2 is 4, and we write it in the number column. And we draw a line. And just as we did over here, we subtract. But you must use brackets here, or you must think that there are brackets there. Okay? You'll see why in a minute or two when I do a harder example. Okay? Because if that plus sign was a minus sign, there would be a sign change. Okay, as there is here. Okay, so you've multiplied this 2 with the 2x there, and the 2 with the 2 there to get 4. So now we subtract. So we go 2x minus 2x. Well, that goes to 0. And we go 3 minus plus 4. Well, this minus plus 4 is going to go to minus 4. And that's going to give us minus 1. And this is our remainder. Okay? Now, just as with the number example, we wrote the remainder as a fraction, we do exactly the same here. This minus 1 is a remainder, but it is the numerator of a fraction of minus 1 over x plus 2. Just as when we did this 2, we were dividing by 5, and this 2 became 2/5 in our numerical answer. So this minus 1 becomes minus 1 over this x plus 2. So if we look at the final division, we can say that this 2x plus 3 divided by x plus 2 is really 2, and that comes from our answer up there, this 2, okay, minus, because of the minus sign there, minus 1 over x plus 2. Now this, of course, what we've really done is we've split this division here up into a whole number minus another thing there. And all of this we can integrate. We can't integrate that straight away without splitting it up like that. So let's integrate it. Okay, so there it is. What I'm doing is I'm rewriting the integrand here into that form there. And this, of course, is two separate integrations. It's the integration of 2 dx, which is going to give me, excuse me, 2x. And then I'm going to integrate this 1 over x plus 2. Now, you should know by now that when you do this, you can say let u equal x plus 2. And so du equals dx. And so you can straight away integrate that into the form of, well, you're integrating 1 over u du, which gives us the natural log of u plus c, but u, of course, is x plus 2. So there's the final answer there. Okay, now I'm going to stop here because the next example I'm going to give you is a quite more complicated one in the sense that the long division of the polynomial, this thing here, is slightly more intricate. Okay, but we do exactly the same thing, and I will show you this in the next video. Okay, thank you very much. How do I stop this thing? Oh, there we go.